through the ability to change the shape and the size of their basic flying mechanism, the wing. And there's a wonderful example of that just over here.
Tonight, we're going to talk about something that keeps astronomers up at night. Not because they're scared, but because they're confused. Actually, genuinely confused. Because out there in space, we've discovered things that don't make sense. Things that shouldn't exist according to everything we know. Things that break the rules. And I'm not talking about science fiction. I'm not talking about theories or speculation. I'm talking about real observations, things we've actually seen and measured, things that are out there right now doing whatever strange thing they do. And we have no idea why. Over the past few decades, as our telescopes have gotten better, we've stumbled across discoveries that have left scientists scratching their heads. Some challenge our understanding of physics. Some suggest there might be processes in the universe we don't know about yet. And some are just plain weird. Before we dive in, if you enjoy these deep explorations into the mysteries of space, a quick like or subscribe would really help the channel. It's a small thing, but it makes a big difference. Now, I'm going to show you 4 discoveries that genuinely puzzle scientists. Each one breaks the rules in its own way. And by the end, you'll see why these mysteries might be telling us something profound about the universe itself. Let's get into it. Let me start with something that happened on August 15th, 1977. A man named Jerry Eman was reviewing data from the Big Ear radio telescope at Ohio State University. The telescope was part of SETI, the search for extraterrestrial intelligence. Every day it scanned the sky, listening for radio signals that might indicate intelligent life somewhere out there. Most days, the data was boring. Background noise from space. Nothing unusual. But on this particular day, Eamon saw something that made him grab a red pen and write, "Wow," in the margin of the printout. That's why we call it the wow signal. The signal lasted 72 seconds. During that time, it was 30 times stronger than the background noise. It came from a specific direction in the constellation Sagittarius. And here's what makes it so interesting. The signal's frequency was around 1,420 megahertz. That's right near the hydrogen line, a natural frequency associated with hydrogen atoms. Why does that matter? Because hydrogen is the most common element in the universe. If you were an alien civilization trying to send a signal that other civilizations might recognize, you might choose a frequency related to hydrogen. It's like choosing a universal language based on something everyone would know. The Big Ear telescope had 2 receivers that scanned the same patch of sky 3 minutes apart. The signal showed up on the first receiver, but not the second. That means it lasted less than 3 minutes, probably closer to 72 seconds based on the data we have. Since 1977, astronomers have gone back to that same spot in the sky dozens of times. They've used more powerful telescopes. They've listened at the same frequency and nearby frequencies. They've searched for any sign of the signal returning. Nothing. The wow signal was a one-time event. Now, let me be clear about the uncertainty here. The signal could have been artificial or natural. Some scientists have suggested it might have been a signal from a passing comet. Comets can emit radio waves when the solar wind interacts with their hydrogen clouds. But there's a problem with the comet theory. The signal was incredibly narrow band. It occupied a very specific frequency. Natural sources usually produce signals across a broader range of frequencies. The narrowness of the wow signal is more consistent with an artificial source, something deliberately transmitting on a chosen frequency. So what was it? Honestly, it remains unexplained. Nearly 50 years later, the wow signal remains one of the most intriguing, unexplained observations in the history of SETI. The fact that it never repeated is both frustrating and significant. If it was an alien civilization, why would they only transmit once? Maybe they were using a lighthouse strategy, sweeping a beam across the galaxy, and we just happened to catch it for a brief moment. Maybe it was a one-time broadcast. Maybe it wasn't meant for us at all, just an accidental spillover from some other communication. Or maybe it wasn't aliens at all. Maybe it was some natural phenomenon we don't understand yet. The universe is full of processes that emit radio waves, pulsars, quasars, magnetars. We're constantly discovering new types of radio sources. Maybe the wow signal was something natural that we've just never seen before or since. The truth is, the answer may never come. The signal lasted 72 seconds in 1977 and never came back. It's a mystery frozen in time. Somewhere out there, in the direction of Sagittarius, something sent out a powerful narrowband radio signal, and we happened to catch it. That's either the most incredible coincidence in the history of astronomy, or it's evidence of something extraordinary. Either way, it's strange. And it's why, almost 5 decades later, people are still talking about the wow signal. Now, let's talk about something that's happening right now, a star that's been driving astronomers crazy since 2011. Its official name is KIC 8462852, but most people call it Tabby's star, named after astronomer Tabitha Boyajian, who led the research team studying it. Tabby's star sits about 1,460 light-years away. It looks like an ordinary star, slightly larger and hotter than our Sunday. Nothing about it should make it special. But in 2011, the Kepler Space Telescope noticed something weird. Stars dim sometimes. That's normal. If a planet passes in front of a star from our perspective, the star's light drops slightly. That's how we detect exoplanets. When Earth passes in front of the Sun from another star's perspective, the Sun's light would dim by about 0.01%, tiny but measurable. Jupiter, being much larger, would cause the Sun to dim by about 1%. That's the kind of dimming we expect from planets. Regular, predictable, small. Tabby's star doesn't do that. In 2011, its light dropped by 15%. Then it came back. In 2013, it dropped by 22%. Then it came back again. The dimmings were irregular. They didn't repeat at predictable intervals. They lasted different amounts of time. 22% is enormous. That's not a planet. A planet the size of Jupiter would only block 1% of the star's light. To block 22%, you'd need something absolutely massive, something as large as the star itself. Here's where things got really interesting. Someone suggested it might be an alien megastructure. The idea comes from a hypothetical concept called a Dyson sphere, proposed by physicist Freeman Dyson in 1960. Dyson wondered what an advanced civilization would do if it needed enormous amounts of energy. Eventually, he reasoned, they might build structures around their star to capture its energy output. Not a solid shell, that would be impossible, but a swarm of energy-collecting satellites orbiting the star. If you were building something like that, it would block varying amounts of the star's light as the structure orbited. It would be irregular. It would dim the star by large amounts. It would look exactly like what we were seeing with Tabby's star. Now, before you get too excited, let me be clear. Most astronomers don't think Tabby's star is an alien megastructure. The alien hypothesis was always the least likely explanation. But here's the thing, we had to consider it because we couldn't explain the observations any other way. That's how weird this star is. So if it's not aliens, what is it? The latest observations suggest that Tabby's star might have a large debris field around it, perhaps from a destroyed planet or a massive collision or some other catastrophic event. The debris blocks light irregularly as it orbits. This is the current leading explanation, but it's not fully satisfying. The full picture remains unclear. And here's what makes this even stranger. Tabby's star is still doing it. We've now watched this star for more than a decade. It keeps dimming in weird, unpredictable ways. We have multiple data sets from different telescopes. The phenomenon is real. It's not a measurement error. It's not a glitch. Something is actually blocking the light from this star in ways that remain puzzling. As of 2025, Tabby's star remains one of the strangest objects in the sky. Out of hundreds of billions of stars, this is the only one that behaves like this. We've never seen anything else quite like it. Maybe one day we'll figure it out. Maybe we'll discover it's a natural process we just haven't encountered before. Or maybe, just maybe, it's something else entirely. Something we haven't even thought of yet. Now, let me tell you about something discovered in 2019 that absolutely shouldn't exist. They're called odd radio circles, or ORCs. The name is perfect because they are odd, they're circles, and we only see them in radio wavelengths. Here's what they look like. If you point a radio telescope at certain parts of the sky, you see a perfect circle. The circle is enormous, hundreds of thousands of light years across. And here's the weird part. There's usually a galaxy at the center. The first one was discovered by a team led by astronomer Ray Norris. They were using the Australian Square Kilometre Array Pathfinder telescope, surveying the radio sky. When the team processed their data, they found these circular structures. At first, they thought it was a processing error. Circles are suspicious in astronomy. Nature rarely makes perfect circles. But when they checked the data carefully, the circles were real. They found 3 more. Then other telescopes confirmed them. As of 2025, we've found about a dozen ORCs. They're rare, they're large, and their origin remains a puzzle. Astronomers see circular things in the sky sometimes. Supernova remnants can look circular. They're the expanding shells of debris from exploded stars. But supernova remnants are much smaller. ORCs are too large and too far away to be supernova remnants. Some galaxies have radio lobes, where jets from a central black hole shoot matter out into space. These can create circular structures when viewed from certain angles. But ORCs don't match the characteristics of radio galaxies. The central galaxies don't show the active supermassive black holes that would be needed to create such structures. So what are they? Honestly, we don't know. Scientists have proposed several theories. Maybe they're shock waves from massive explosions in the center of galaxies. If a galaxy went through a period of intense star formation, or if its central black hole suddenly became active, it could create a blast wave that expands outward. Over millions of years, this wave could create a spherical shell of radio emission. But if that's the case, why don't we see more of them? Galaxies go through active phases all the time. We should see these structures more often. Another theory suggests they might be related to merging galaxies. When 2 galaxies collide, all sorts of crazy things happen. Maybe the collision creates shock waves that expand outward as spherical shells. But again, galaxy mergers are common. ORCs are rare. What makes ORCs particularly fascinating is that they represent something new. We've been studying the radio sky for decades, but ORCs only showed up when we built more sensitive radio telescopes. They were always there. We just couldn't see them until recently. This tells you something important about astronomy. The universe is full of things we haven't discovered yet, not because they're hiding, but because we don't have the tools to see them. Every time we build a better telescope or observe in a new wavelength, we find something unexpected. As of 2025, ORCs remain unexplained. We know they exist. We know roughly what they look like, but we don't know what causes them. They're strange structures in the radio sky, waiting for someone to figure them out. Now let's talk about something that breaks the rules on a truly cosmic scale. In 2021, astronomers discovered an enormous structure that challenges one of the fundamental principles of cosmology. It's called the Giant Arc. It was discovered by Alexia Lopez, a PhD student at the University of Central Lancashire. The Giant Arc is a structure of galaxies that spans about 3.3 billion light years. That's not the distance to it, that's how large it is. The structure itself is 3.3 billion light years across. To put that in perspective, light takes 3.3 billion years to travel from one end of this structure to the other. Now, why is this a problem? Let me explain. In cosmology, there's something called the cosmological principle. This principle states that when you look at the universe on large enough scales, it should be roughly uniform. No matter which direction you look, you should see roughly the same density of matter. The universe should be homogeneous and isotropic at large scales. This principle is fundamental to our understanding of the universe. It's built into the standard model of cosmology. It's supported by observations of the cosmic microwave background, which shows that the early universe was remarkably uniform. But the Giant Arc challenges this principle. It's too large. According to calculations based on the standard model, structures shouldn't be able to grow larger than about 1.2 billion light years. That's the theoretical limit based on how gravity has had time to pull matter together since the Big Bang. The Giant Arc is nearly 3 times larger than this limit. If this structure is real, and it appears to be, then either our theoretical limit is wrong, or something weird is going on. Maybe the cosmological principle doesn't hold as well as we thought. Maybe the universe is lumpier than we believed. Maybe there are processes we don't understand that can create structures larger than theory predicts. Some astronomers have questioned whether the structure is real or just a statistical fluke. When you look at the distribution of galaxies, you can sometimes see patterns that aren't really there. Your brain looks for connections. You might see a line or arc of galaxies that's just a coincidence. But Lopez and her team did careful statistical analysis. The probability of the Giant Arc being a random arrangement is about 1 inch 6,000. That's pretty low. The structure appears to be real. As of 2025, the Giant Arc remains controversial. Some astronomers are convinced it's a real structure that challenges the cosmological principle. Others are more skeptical. What's clear is that the universe at the largest scales is more complex than we thought. These enormous structures, whether they turn out to be real anomalies or something else, are pushing us to think harder about how the cosmos is organized. And that brings me to something important about all 4 of these mysteries. Here's something interesting to think about. All 4 of these mysteries might seem unrelated. A radio signal from the 1970 seconds, a star that dims irregularly, giant radio circles, structures that are too large. They seem like completely separate mysteries, but maybe they're not. Maybe they're all telling us the same thing, that the universe is more complex than our current models suggest, that there are processes, phenomena, or physics we don't fully understand yet. Think about it. The WOW signal tells us there are radio sources we haven't identified. Tabby's star tells us stars can behave in unexpected ways. Odd radio circles tell us galaxies can create structures we're only beginning to see. The giant arc tells us the universe might not be as uniform as we thought. Each mystery on its own is just an oddity, something strange we need to explain. But taken together, they paint a picture of a universe that's still surprising us, still showing us things we didn't expect. This is actually normal in the history of science. When you're on the edge of understanding something new, you start seeing anomalies, things that don't quite fit. At first, they seem like isolated problems, but eventually, someone connects the dots. Someone realizes these anomalies are all symptoms of something bigger, something we haven't understood yet. That's how we discovered relativity. In the late 1800s, there were several problems in physics. The orbit of Mercury didn't quite match predictions. The speed of light seemed to be constant, regardless of how you measured it. These seemed like separate issues. Then Einstein came along and showed they were both explained by the same new theory. Relativity connected the dots. Maybe that's what's happening now with these cosmic mysteries. Maybe they're all pieces of a puzzle, and someday someone will figure out how they fit together. They'll develop a new theory or discover a new phenomenon that explains all of them at once. Or maybe each mystery has its own separate explanation. We won't know until we figure them out. But the possibility that they're connected, that they're all telling us something fundamental about the universe that's exciting, these strange discoveries teach us something important. Science isn't about having all the answers. It's about honestly confronting what we don't know. When we discover something we can't explain, the scientific response isn't to make up a story or ignore it. The response is to admit we don't know, to study it carefully, to think creatively about possible solutions. The universe is strange, wonderfully, beautifully strange. And that strangeness is what makes it worth studying. Thank you for joining me on this journey through some of the strangest things scientists have discovered in space. If you enjoyed this exploration, a like or subscribe would really help the channel grow. And remember, the universe is full of mysteries. We've barely begun to understand it. Good night.